Hello, everybody. So we are continuing, kind of winding down our unit on conversions. So today we are just working on doing a little bit more complex of a problem. Okay. So we're going to solve word problems involving conversions again. So let's look at our example. Complete the example below, then solve problems 1 through 8 using the math reference sheet as necessary. And that would be your conversions. But look at the example. Pierre is 53 inches tall. Pilar is 5 feet tall. Who is shorter? How much shorter is the shorter person? Now, really, there's not a whole bunch of reason to do this with a conversion, like they're doing it over here. 12 inches is 1 foot. So I would just literally go feet, inches, and you can just put them in order. 1 foot, 12 inches, 2 feet, 24 inches, 3 feet, 36 inches, 4 feet, 48 inches, 5 feet, 60 inches. Okay, and then we have someone who is 53 inches tall. Well, 53 is going to go right in between here. So that means that if Pierre is 53 inches tall and Pilar is 5 feet tall, well, what's the conversion for Pilar? Pilar is 60 inches. Pierre is 53 inches. Therefore, we know Pilar is taller. Okay. And then to find the difference, you just have to do 60 minus 53. And it's already done for us right over here. And we know it's 7 inches difference. All right. So we're going to continue working on this. And there are a couple problems in this lesson. One of them I really disagree with strongly, and we'll kind of talk about that as we go. It involves lifting weights, but we'll kind of keep going. Now, little bonus question today. Anyone know what day the NFL draft comes? Oh, that's going to be a good one. Going to give a little bonus right here. Research it. I don't care if you Google it. Okay. Vanel put together a model train with 25 cars. Each train car is 80 millimeters long. How many meters long is Vanel's model train if there are no gaps between the cars? Show your work. That was reading 1. Here comes reading 2. Going to find the information. Vanel put together a model train with 25 cars. Each train car is 80 millimeters long. How many meters long is Vanel's model train if there are no gaps between the cars? All right, so a couple things that you need to know. So we have, first of all, centimeters. We are going to be going from millimeters to meters. So we have meters, millimeter. 1 meter is 1,000 millimeters. 2 meters is 2,000 millimeters. 3 meters is 3,000 millimeters, and so on. So if I wanted to get from the X side to the Y side, all I would have to do is say X times 1,000 equals Y. And if I wanted to go from the Y side, if I knew the amount of millimeters to go to meters, I would just do the opposite, the inverse. Y, what's the opposite of times 1,000, which is divided by 1,000, will equal X. So if I wanted to go from here to there, it would be Y divided by 1,000 will equal X. All right, and I tried to write that algebraically. If you're more comfortable saying Y divided by 1,000, equals X. Go ahead and do it that way. It doesn't matter to me. All right. So now let's digest what we're looking at here. We have 25 train cars. Okay. 25 train cars. Each is 80 millimeters long times, and this is going to be multiplying it, times 80 millimeters in length. And then if I multiply 25 times 80, I can do that really quick. Okay. So here's 20 plus 5, and then we just have 80 up here. Okay. So I know that 2 times 8 is 16, and I have 2 zeros right here, so that's 1,600 millimeters. And I know that 5 times 8 is 40, with another 0 that I held back. So if I just add those two, 1,600 plus 400, it's going to equal 2,000 millimeters. Okay, well, how many meters is it? If I wanted to go from millimeters to meters, I just do this right here. Y divided by 1,000 equals X. Here is Y, 2,000 divided by 1,000 equals X. Okay, and in this case, X is meters. And 2,000 divided by 1,000 is 2 meters. So hopefully that made a lot of sense as we went. Keep following right along. Okay. Next one. Okay, number 2. Ed solved a puzzle 3/4 of a minute faster than Brett. Brett solved the puzzle in 135 seconds. How long did it take Ed to solve the puzzle? Show your work. Okay, so first of all, I always go back to tables when I'm dealing with these conversions. I always want to know, my minutes to seconds ratios or my conversion. So I know if I go minutes on this table, seconds on this table, all right, I know that 1 minute equals how many seconds? Well, that's going to be 60. But I'm dealing with 3/4 of a minute. Now, I could do a fancy thing right here, and I could say, okay, 3/4 of 1 minute, and I can figure out what that's worth, but I'm going to start with the halving principle. I know that 1 minute is 60 seconds. Well, I know that 1/2 of a minute is half of 60. What's half of 60? 30. And let's decompose these into quarters. What's half of a half? Half of a half is going to be a quarter. So a quarter, so that is half of 30, and that's going to be 15 seconds. So if we go straight down, I have 1/4 of a minute is 15 seconds. 1/2, which is the same as 2/4, is 30 seconds. So as I'm going down by quarters here, 1/4, 2/4, 3/4, you can tell that I'm adding by a quarter on the X side, and I'm adding 15 on the Y side. So 3/4 would be 45 seconds. Okay, now I've got probably everything I need to solve this problem. Ed solved the puzzle 3/4 of a minute faster than Brett. Brett solved the puzzle in 135 seconds. How long did it take Ed to solve the puzzle? Okay, so if I know that Brett solved it, okay, right here is Brett, and it took Brett 135 seconds. That is from here to here. But I know that Ed solved it 3/4 of a minute faster. Well, 3/4 of a minute is 45 seconds. So this is how long it took Ed to solve the puzzle. Okay? Ed, 3/4 of a minute faster. So as you can tell, all we're going to do, and here's the difference in how much faster that it took him right here. We are solving for this amount right here. So I'm going to take Brett's 135 seconds minus, well, what's 3/4 of a minute? 45 seconds. I'm going to give you a little pause right here. So 3/4 of a minute minus 45 seconds. 5 minus 5. Go ahead and put it in. 13 minus 4, and you should have your answer. So 5 minus 5 is 0. Cover that up. 13 minus 4 is 9. He solved it in 90 seconds. All right, let's move on to our next one. Now, this is the question that I don't like. It honestly is not, it's not correct fundamentally what they're saying. I get what they're saying, but it really isn't it. So, and I'll tell you the logic on this, and it's kind of funny. Bennett exercises by lifting weights. He can lift 200 pounds 3 times. Now, I want you, and that's without resting between lifts, I want you to think about this while I'm just saying this. If you can only lift 200 pounds on a bar, like this bar down here, and that's all you can lift, if you can do it once, it's 200 pounds. If you can do it twice, you still lifted 200 pounds. And of course, if you lifted it a third time, it's 200 pounds. This is fundamentally wrong what they're about to ask, but it says, which equation shows a correct way to find the total number of ounces he can lift without resting? Well, this isn't, it's not a combination lift. It doesn't mean that you can actually lift 600 pounds just because you can do this 300 times, okay, or 3 times. So let's look at which one it is. So I really don't like it, but it's saying he can lift 200 pounds 3 times without resting between lifts. So they're wanting to show this. And then, which equation shows a correct way to find the number of ounces N he can lift without resting? So I know that pounds to ounces, 1 pound is 16 ounces. And this is really all I need to know about this. They're trying to say this is 200 pounds 3 times. And then what we're going to do right after that is we're going to multiply it by 16 ounces. Okay? And that's telling you basically if I took 200 pounds, I could multiply it by 16, and that would tell me how many ounces he could lift. Probably the dumbest question I've ever seen, ever. And because it's so stupid, we're going to move on. It's fundamentally not right. I work out, and I don't like things like this. So, hey, yay, amen. Here we go. So, number 4. A football field is marked every 5 yards. Garrett ran from the first mark to the 11th mark. Which expression can you use to find the number of feet Garrett ran? Okay, this is a little bit better question. Okay, so let's just write some things we know. So we've read it once. Let's find some things that we know. A football field is marked every 5 yards. Okay, Garrett ran from the first mark to the 11th mark. Which expression can you use to find the number of feet Garrett ran? Okay, notice they didn't use an 11 in here because that's the first mark. So he actually only ran the difference of 10 marks on a football field. Okay, so Garrett did what? He went 10. Okay, he ran 10 marks times every 5 yards. Now, if we go with a conversion of yards to feet, 1 yard equals 3 feet. Okay, 2 yards, 6 feet. Well, 10 times 5 would be 50 yards. And what would 50 yards be? Because if we are going from the x side to the y side, it would be x times 3 equals y. So I know that I'm going to go right here, 10 times 5, and then I'm going to multiply it by 3 to figure out my feet. 10 times 5 times 3. Okay, now, so that should be a really solid answer for you, understanding this. It's a little bit better question than the last one, number 3, which I actually felt like it made me dumber to read it to you. So that's okay though. Mr. Wayne's class, number 5, collected empty soda cans for a recycling project. Each of the 20 students had to collect 40 cans. Okay, so think about that. So if we did that in our class, every single student would have to collect 40 cans. Each can has a mass of 15 grams. How many kilograms of cans did the class collect to recycle? Now, much better question, all right? So let's kind of look at what we should do. Now, this would have been awesome. Just kind of note to the publisher if they ever happen to stumble upon my lesson. If they wouldn't have had these stupid cans right here, and they would have actually thought, oh, this would be a great time to give someone some space to do a problem. So I'm just going to do this for them because they're so moronic. And I'm going to put this in here for them because obviously they've never been a student trying to do a math problem with no space. So let's just kind of put these down right here. Let's go find our information. Mr. Wayne's class collected empty soda cans for a recycling project. Each of the 20 students had to collect 40 cans. So right now you should be seeing something like 20 times 40. Each can has a mass of 15 grams. How many kilograms of cans did the class collect to recycle? All right, so if I had 20 students and each of them had to collect 40 cans, we're talking about 20 times 40. 20 students times 40 cans. Okay, now each can has a mass of 15 grams times 15 grams. All right, so now I want to know what I'm going to follow just orders of operation right here on this expression. And I'm going to say 20 students times 40 cans. That's going to be 800 cans. Okay, and each can has a mass of 15 grams. So 800 times 15 grams. Okay, and I can just kind of do that right over here. 800 times 15. So here's 800. Here's times 15. I'm going to do 15 times 8. I'm going to flip this over and do it this way. 15 times 800. Take those two zeros off. Put them down here. Now I'm just going to do it 8 times 5, 40. Put down the 0, carry the 4. 8 times 1 is 8, plus 4 is 12. And that's going to leave me with 12,000 grams. Now, this question is essentially asking me how many kilograms of cans did the class collect to recycle? Now, think about what kilograms to grams are. Okay, so if I have 1 gram, okay, so if I went grams to kilograms, 1 gram is just 1/1000th kilogram. Okay, or you can look at it this way, 1 kilogram to grams, 1 kilogram is 1,000 grams. So if I have 12,000 grams, okay, I can go all the way over here. I can just work my way down because my x side here, my y side here, it's x times 1,000 equals y. 2 kilograms, 2,000, 3 kilograms, 3,000. Well, what happens when I have 12,000 grams? So over here I went 12,000. To get from the y side to the x side, I just divide it by 1,000. Well, that's going to be 12. Now, I'm going to do it a little bit different. So your answer overall would be 12, but I'm going to show you how I would do this as our conversion. So 12,000 grams to kilograms is going to be the same as saying 12,000 times 1 gram. That's the same as saying 12,000, and now I'm going to do my conversion, grams to kilograms times 1/1000th kilogram. That would leave me with 12,000 divided by 1,000. The zeros would cancel each other out, and that's going to leave me with 12 over 1, which equals 12 kilograms. All right, so our answer would be B. Okay, next question. Susan is stacking boxes on a shelf. Now, I know I haven't reminded you today, but make sure you pause as you need to. Okay, you can work these problems out and do just fine. Susan is stacking boxes on a shelf. Each box is shaped like a rectangular prism, like this, and has a length of 2 feet, length, a width of 15 inches, width, and a height of 3 inches as shown below. Now I looked at this immediately and thought, oh, we're going to be doing volume. Then we weren't doing volume. Susan will stack the boxes on top of each other as shown below at the right, like this. Okay, the space above the shelf is 1.5 yards high. So from the bottom of the shelf to the top of the shelf would be 1.5 yards high. Now let's go ahead and just kind of look for some information. What is the greatest number of boxes Susan can stack on the shelf? So reading this, I've made sense of it. How many of these boxes will stack on this shelf when placed on the shelf this way to the very top? All right. So the only thing I really need to know is how tall in height the box is. So take a look. It has a length of 2 feet, width of 15 inches, a height of 3 inches. Okay. So this number right here, 3 inches tall, is all I need. So let's take a look. Let's go yards to inches. Okay. So I know that 1 yard, okay, is 36 inches. But now I can see that it's 1.5 yards. So let's just do that halving principle again. What is 1/2 of a yard? Half of 36 is what? It's 18. Okay. Now I can figure out how tall this is in inches. 1.5 yards is 36 plus 18, which equals 54 inches. And now I want to know how many 3-inch boxes can go all the way, be stacked on top of each other till we get to the top with as little a gap as possible. Maybe it fits perfectly. So I'm going to take this 54 inches. Okay, here's how high it is. How many times can I get 3 into 54? So I'm going to take 54. I'm going to divide it by 3-inch tall boxes. And I know, using partial product, that there are 10 threes in there at least. 10 times 3 is 30. Subtract. 54 minus 30 is 24. And now how many threes are in 24? There are 8. Therefore, 10 plus 8 is 18 boxes. All right. How are we doing? Hopefully you're just following right along, keeping up. We're going to go on to number 7. Lesson's going really fast. We're almost done. All right. Emma keeps track of the time she spends on a report each week. Week 1, 1.5 hours research, 3/4 hours reading, and 45 minutes on outline. Week 2, 2.25 hours writing, 45 minutes editing, and 1/2 hour on the cover. How much time did Emma spend on her report the first week? Show your work. Okay, so let's break this down. Week 1. How much time did Emma spend on her report the first week? Show your work. Okay, so let's take this. 1.5 hours plus 3/4 hours plus 45 minutes. Now, one of these things is not like the others. Okay, look how this is in hours, this is in hours, and now this is in minutes. Okay, so I want to turn, let's go hours to minutes. Okay, I'm going to start with 1 hour is 60 minutes. Okay, now I see that this is 1.5. So I'm going to find what the half is. 1/2 hour. Okay, and I know that half of 60 is 30 minutes. And because I did this earlier on an earlier page, I'm going to just cut this down. I'm going to decompose half into quarters. So 1/4 of that is just going to be half, because 2/4 is a half. So half of a half is going to be 15. So I can just now keep adding 15 minutes. 15, 30, 45. And now remember, 1/2 is the same as 2/4. So 3/4 of an hour would be 45. Okay. Now, if I want to get my 1.5 hours, okay, I know that's the same as saying 60 plus a half hour, which is 30. So that's going to be 90. All right. Now I can just find this fractionally. 1.5 hours plus 3/4 hours. And what do you know? Here's another 45 minutes is, I'm going to just trade it, 3/4 hour. Okay, this is the one that I converted. So now I've left with 1.5 plus 3/4 plus 3/4. Okay, so now all I've got to do is I'm just going to add these two right here. 3/4 plus 3/4, 6/4. And 6/4 is the same as 6 divided by 4. And that's 1 time. 1 times 4 is 4. And That's going to leave me with 2. There's nothing left to bring down. So this is 1 2/4. So that leaves me with 1 2/4 plus 1 1/2. And we know that 1 1/2 is the same as 1 2/4. So I've got 2 things right here. 1 2/4 plus 1 2/4. That's going to be 3 hours. Okay, first answer complete. Next one. How much more time did Emma spend on the report on the second week than she spent the first week? Okay, same type of problem, except for once we find our total, we've got to subtract this number from that one. And look at this, how it kind of gives it away. How much more time did she spend in the second week? It's telling us that our answer will be greater than 3. Okay, now we just have to figure out how much more. So I'm going to take 2 1/4 hours writing, 2 1/4 hours, 45 minutes, okay, plus 1/2 hour. All right. Now, which one of these things is not like the other? So these are both in hours. This is in minutes. How much of an hour is 45 minutes? Go right back up to our chart. 45 minutes is 3/4. So I'm going to substitute. I'm going to convert 45 minutes to 3/4 hour. Okay. So now rewrite it. 2 1/4 hours plus 3/4 plus 1/2 hour. Okay. Now look at this one. This pairs up really nice. 2 1/4 plus 3/4. Well, I know that 3/4 plus 1/4 is 4/4. So that's 1 whole plus 2. So this, if I just pair these together, okay, that's going to equal 3 hours plus 1/2 hour. What's that equal? 3 1/2 hours. Now, this is not the whole answer. How much more time did Emma spend on the report the second week than she spent the first week? Take your answer here, 3 1/2 minus 3 hours up here. 1/2 minus 0 is 1/2. The 3's cancel each other out, so she spent 1/2 hour longer. All right. Last question, if you can believe it, how fast this one went. All right. So, and I scratched something out because I didn't like the question. Teresa has 800 milliliters of water. Sarah has 5 liters of water. Tell why Sarah has more than Teresa. Okay. Now, this says without converting units, tell why. I didn't like that because you're going to convert mentally. So why have a pretend chase that we aren't converting? We are. Okay, so let's go liters to milliliters. So 1 liter is 1,000 milliliters, right? 2 liters is 2,000. But she has 800 milliliters of water. Sarah has 5 liters of water. So let's, first of all, figure out something about Sarah here. So if she has 5 liters, to get from our X side, which is liters, to our Y side, all we have to do is say X times what? How do I go from 1 to 1,000 using multiplication? X times 1,000 will equal Y. So 5 times 1,000 will equal 5,000 milliliters. Okay, so that's important. Sarah has 5,000 milliliters. Now my problem is pretty much almost done. Tell why she has more than Teresa. Okay, and I can pick milliliters or liters. I'm going to stick with milliliters here because then I don't have to divide this and show that this is 8/10 of a liter, even though that's what it would be. If I wanted to go the other way, I could have said y divided by 1,000 equals x, y divided by 1,000 equals x. So I could have said 800 divided by 1,000 will equal 0 and 8/10 liters. But I'm not going to do that. I'm just going to simply go 500, or I'm sorry, 5,000 milliliters minus 800 milliliters. And then simply, we're going to get our answer, 0 minus 0, 0, 0 minus 0, 0, 50 minus 8, 4,200 milliliters. Okay, and that's because when you are converting liters to milliliters, you have to understand 1 liter is 1,000 milliliters. Okay, hopefully there's no questions. Keep working on your Edpuzzles. They're very valuable. Okay, and we're going to move on. We have a test coming right up. See you later.